Well, here we are with another test. This one here is going to have some alignment and EPS questions. It's a little more advanced than the other tests, but it's a lot of fun. And so let's jump in here and see what we can do about this. Question 1. A vehicle pulls to the left. The alignment reading shows the left front camber at +5 and the right front camber at plus 0.5 degrees, it's a half a degree, and a little more than that on the right. Is it pulling toward the most positive camber, pulling toward the most negative camber, pulling toward the highest caster angle, pulling toward the lowest steering axis inclination angle? That's a fairly easy question. We've got a little illustration here as to why that is. Pulling toward the most positive camber. All right, he's going into a positive camber situation here. See him leaning? It's going to roll the way he's leaning. It's like a motorcycle fork or a bicycle, something like that. Anybody that's ever ridden a motorcycle or a bicycle understands that without realizing it. Question 2. Diagnosing an EPS system, the steering wheel heavy only when turning in one direction. Which component should be checked first? Steering rack for mechanical bind, EPS motor for a partial internal short, the torque sensor signal for an offset, or battery voltage drop during heavy steer. What do you think about that? You need a lifeline? Tink, 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 tink. All right, whenever you do that, you're supposed to check the torque sensor signal for an offset. If one signal, if it's skewed or imbalanced, the ECU won't command the motor to provide equal assist in both directions, that's something really important there. All right, let me see here now. You can read those little explanations in the boxes down there. I don't need to read those to you necessarily. Question 3. Which angle is typically adjusted first to establish the vehicle center line? Front caster, rear toe, rear camber, front toe. All right, that one is going to be rear toe because you're always supposed to start at the back if there's alignment available back there. Of course, on your vehicles with a solid rear axle, if the rear axle is crooked under there, the thrust line is going to be wrong. But if you start from the rear, if you don't line those rear wheels up first, get your particularly the toe, but the camber and the toe. I always taught my students start at the back, and that's going to give you a nice frame of reference going toward the front. And so once you got that rear set like it was supposed to be, you move to the front and do that. The thrust line, you can see the illustration here, is which way it's pushing. So you're going to do with you're going to make your rear toe adjustment. Question 4. A technician replaces an EPS steering rack and the steering wheel is now off center. What's the required next step? Do you remove the battery to reset EPS memory, index the steering wheel on the spline shaft, adjust the tie rods to center the wheels, or perform steering angle sensor calibration using a scan tool? All right, now modern electric power steering systems rely on the steering angle sensor to determine the wheel position and assist direction. When the steering rack's replaced, see, I'm reading it to you, the physical relationship between the steering wheel and the rack's internal position sensor changes even if the tie rods are correctly adjusted. And so that may throw you for a loop. And you get your scan tool, you get it set up here, you're fixed up, hooked up fat. Question 5. What's the primary function of the caster angle? Does it maximize the scrub radius of the tire and turns, directional stability and steering wheel returnability, properly calibrate steering effort in systems with electronic power steering or electric power steering, or to prevent tire wear due to infrequent slow turning? All right. Directional stability and steering wheel returnability. Now this is a diagram I worked on for a pretty good little while. I drew this from scratch, so I hope you appreciate it. This is obviously your caster angle. As you bring this farther forward, you're going to have, the caster's going to be more negative. The farther back this angle is, and that's your steering axis running through your ball joints or through the bottom ball joint and the strut and all that. But you notice right here, how whenever you turn the wheels, it raises the vehicle up a little bit. And you go back to the center, it goes through the low area, and then you turn the other way, it raises up a little bit. It always wants to go back to the center, and that's going to help you with that. Now, caster can cause a shimmy, but it won't typically cause tire wear, and so remember that. Question 6. What is a common reason electronic power steering systems use a brushless DC motor? It allows the system to operate without an ECU and requires only a 2-wire motor connection, higher efficiency and better heat dissipation, and prevents all magnetic interference with gasoline direct injection. All right, this one right here, this is the ones that have the motor up in there under the dash, instead of out here on the rack. This is the one that how they're fixed up. They got this worm gear, and it operates that, and this spins back and forth real fast. The thing about brushless motors is you can have instant power as soon as you want to take off. So that's why your Teslas and your hybrid vehicles have got the 3-phase motors. Of course they're AC. These are DC. But the long and the short of it is, whenever you throw the juice to that thing, you instantly got full power. On a motor with brushes, there's issues with the brushes. You don't have full power instantly or as instantly as you do with a brushless motor. A brushless motor is more efficient. It's less wear prone. Now, it does require electronic circuits to work, which is going to have that, like I was talking about the other day. If you take a computer fan, a 12-volt computer fan, like you're going to take out of an old computer or a new one that you may have on hand if you build computers like I do sometimes, and you got a 12-volt motor, and it's only got 2 wires going to it from the computer board, and you can clip those wires if you want to play around, and you can connect them with the red to the positive and the black to the negative, and the motor will spin. If you swap those around, it won't spin backwards. It's a brushless motor. All right, pop that fan off of there, you're going to see an electronic circuit built inside the hub of that fan, and that's how it operates, that brushless motor. It drives the current around these windings, and that's mind-boggling when you think about having to try to do that manually. But whenever you're working with electronics, it can do stuff really fast and really efficiently like that. And the point is, it's kind of like a stepper motor. The stepper motors on your idle air control and other stuff like that. It can move it. The stepper motors are cool because it can move it a certain amount of distance, and then it can back up a certain amount of distance without just spinning up really fast and overshooting or something like that. But you got a lot more power and a lot more efficiency with the brushless motor. Question 7 is, excessive toe out on the front wheels will most likely cause A, feathered outside edge tire wear, B, rapid inside edge wear on the front tires, C, vibration in the steering wheel at speed, or D, steering wheel failing to return to center. You got a rapid inside edge wear on the front tires. Vibration in the steering wheel at speed is not going to be there. Steering wheel is not going to fail return to center because of this. That's a caster thing. That means they're scrubbing down the road sideways. We talked about that the other day. And whenever you're scrubbing down the road, this inner side is going to wear out, and it's going to feather this outside edge. So kind of watch for that. Now you drag your finger across, you can feel those little sawtooth edges on the. That's fairly straightforward there. Question 8. Which sensor measures the rate at which the driver is turning? Steering angle sensor, vehicle speed sensor, lateral accelerometer, or steering pressure switch? All right. This is illustration. The steering angle sensor. A steering angle sensor on some vehicles is built into the airbag clock spring, which is not really a bad idea. But if you have to replace the airbag clock spring, obviously you got to have the steering wheel dead center. You may have to go in there and calibrate that thing after you get the clock spring replaced, if the sensor is built in. So anyway, it doesn't need to just know the position of the wheel, though. It needs to know how fast you're turning it. Whenever they put active suspension on the Thunderbirds and stuff, they had steering angle sensor on there, and they would measure if you had more than 400 psi of brake pressure in the lines, or if you turn the steering wheel past, faster than a certain rate, it would firm the suspension up. That was part of what it was looking at, the controller, to do that. But if you whip the wheel quickly to avoid an obstacle, the EPS module increases motor current to provide faster assist. It wants to, it's going to follow what you want it to do. Of course, it's got a sensor in there that's also telling it how hard, force you're turning it and all that. That's another thing that provides steering rate data, that steering angle sensor does. On a vehicle with strut suspension, the right-hand steering axis inclination is out of spec, but the camber is correct. We got loose wheel bearings, upper strut mount worn, tire pressure uneven, or bent control arm or frame. This would be your normal steering axis inclination, and this would be the one that's messed up. All right. It's going to have a bent control arm or frame. The people at the body shop used to send Eddie, the guy that was the front end mechanic, cars over there to line up, and they would say, we need to get you to line this up, because they had done a bunch of body work on it and whatnot. And they had a really nice frame straightener back there too. That was real expensive, Continental frame straightener, I think it was. And they'd bring it over there, and he'd say, this thing won't line up. He couldn't get the camber set or whatever, because it was bent somewhere. The steering axis inclination was off, and it would annoy him because he would go back to him and say, this won't line up, there's something bent. They said, well, why won't it line up? What's bent? Well, they had the frame straightener and the way to measure all that stuff. They wanted a front end guy to give them all that information. They should have been able to figure out with their frame straightener and everything. But if camber is correct but steering axis inclination is wrong, you cannot adjust steering axis inclination because it's a non-adjustable angle. That means there's some damage somewhere, and that needs to be taken care of. Question 10. What is the purpose of electronic power steering system active return? It assists in maintaining lane tracking, helps recenter the wheels after turns, prevents steering wheel shaking, or increases low speed parking assist. See them algorithms over there. It helps recenter the wheels after the turns, believe it or not. It assists the caster part of it, and if it sees the driver has let go or reduced torque, it knows where zero is, and so it's going to help you pull it back to zero. It makes it, in other words, it aids the natural caster thing in doing that. So that's going to be the end of that particular presentation there. I had a video I could have played of all my students, but I don't really want you to see their faces and everything. There was a 2008 Chevy SUV. One of them came in. Anyway, it had electronic power steering on it, electric power steering. And I knew it had electric power steering, and we were doing steering and suspension that day at the college. And so I had the girl that owned the vehicle pull it into the shop, and I says, I'm going to open the hood and just sit in the car. I'm going to have these guys tell them to check your power steering fluid. And I says, I opened the hood, and all the students came out of the classroom. And, this was years ago. And I says, I need you guys to check the power steering fluid on this. And they looked under that hood for 10 minutes trying to find, if I was doing that for the first time, I would go over to where the pulleys are, and I would look to find the power steering pump pulley. And that's how I'd find the pump. And then I would go, and usually it'll have a remotely mounted reservoir that's up there in your face. This one didn't have one. They were pointing at the oil filler cap and all kinds of stuff trying to find it. And they were sort of punked whenever I told them to do that. On another occasion, to play a trick on the students, when I was teaching brakes, I had this little 98 Ford Ranger I've talked about in here before. I took the calipers off of that thing before they got there and put them on opposite sides of the truck so that the bleeder was on the bottom instead of the top. And I said, okay, today I'm going to assign you guys you two guys here to go into the other shop over there and bleed the brakes on this Ranger. Here's a gallon of brake fluid, use as much of it as you need and all that kind of stuff. They worked on that thing on that hot summer day for 2 hours trying to bleed the brakes. And then they were good natured when I told them what was wrong. They just laughed, you know. But if you can't look at it and tell that the air is going to go up and the bleeder's on the bottom, you're just really not thinking clearly. They didn't know. There was another one. We had a Crown Victoria, old police car that had lots and lots and lots and lots of miles on it, and it had a misfire on cylinder number 2, and we hadn't worked on that one a lot yet. But I had this one student that I said, he was used to me planting bugs. You know, I would pull a wire back in a fuel injector, or I would bend the gap shut on a spark plug and dip it in oil and put it back in there or something like that to make a skip. So they got used to second guessing me and going after the bugs I planted, which planting bugs is not as easy as you might think sometimes. I can talk about that later. But it was funny to me how I had him pull this. I said, Michael, pull this Crown Victoria in here and find out why it's skipping on cylinder number 2. And he worked on that thing for a solid hour, and he could not figure out what was going on with it. He says, I can't figure out what you did to make this skip. Everything seems like it's the way it ought to be. I said, have you checked the compression? He says, well, no. I mean, how would you do anything to change the compression? I said, I didn't do anything. This one has a problem. And you missed it because you were looking for a bug. And see, that was one of the reasons that live work in an automotive shop situation, when you're teaching automotive, is a lot better than working on bugged trainer vehicles. They can find a bug on a trainer vehicle, but they're constantly trying to look, figure out what you did, and that kind of thing. It's a pain, trying to figure out ways to get those guys to think on their feet instead of just trying to second guess. Another thing that happens is the morning students that first came in there. I had actually jimmied the wires going to the fuel pump on this Bronco that I had so that it wouldn't start. And I told them, find out why it won't start. Well, it didn't have any fuel pressure because the fuel pump was unplugged. If you were listening, you could tell you didn't hear the fuel pump there on the frame. And so that one guy worked and 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 finally figured it out. It took him an hour. And so some other students came in and I gave them the same worksheet. And I saw him over there with his hand up, talking behind his hand to one of the students that had just drawn that worksheet, and the student went right to the problem. Now, my question was the student that went right to the problem better off because he was told where to look for the problem? The first guy that told him was not helping him. He thought he was helping him, but he wasn't. He had information. He was like a spy. He had information that he felt like would benefit the kid, but the kid was actually worse off because he didn't learn how to find the problem. So a lot of times I told him, I said, fixing the car is really important and making sure it's safe when it leaves here if it's a live work job, but learning how to do the job right is why you're here. And learning how to find out what the problem is another reason you're here. And a lot of them just didn't understand that. Okay, I've been talking for a little while now, just rambling. I hope you guys enjoyed this. Let me know what you thought of this one. Let me know if you need another one that is a little more advanced than this one, and I'll see what I can do to put that together for next week.